let's now try to discharge the second sequence that we formulated earlier, which is about the island n events with respect to the concrete invariance condition number 5, which is about the safety constraint, about a one-way bridge over here. Of course, you can see A prime over here has been replaced by A minus 1. You can definitely look up the action for the island n events over here, right? That's something we spoke about when we formulated the sequence. And how do we prove it? Right, so as usual, I'm going to give you 2 chances to really try to prove it by yourself before comparing with my answer, right? Right, chance number 1. And let's say without any of my hints, can you try to prove this particular sequence over here by using only the inference rule that we cover in the 2 example sets? You can now pause the video and think about it. Alrighty, assuming that you thought about it, and if you haven't got your answer yet, if you really need some hints, here you go. Here are the hints. But don't be spoiled too much, because later on in the test or exam, you may not be given this kind of a hint. But of course, just I want to keep you going. But I definitely want to do your exercises independently for other sequence, the other remaining 8 sequence, which I mentioned before. All right, for this one here, let's see over here. Okay, so hints, this will be your second chance to really do the proof by yourself before you compare with my answer. I'm going to show you the process as well, some insights. So these will be the relevant inference rules that you may actually use to prove this particular sequence, the second one. Right, second chance. You can now pause the video and think about it. Alrighty, I really hope that you already got your answer. In that case, you can feel free to skip the video. Otherwise, if you really enjoy my explanation, if you really need it, please stay tuned. And then we're going to do it quickly. Okay, this proof is definitely not very difficult, just slightly more complicated than the earlier one. Right? You can see here what we want to do is we want to do this one over here. Right? You can see the goal itself is really like a disjunction. Meaning that maybe at some point, or maybe in the beginning, we may want to choose either to prove this or to prove that, right? Either one is actually okay, right? That's actually according to the or rule over here, right? You can see for disjunction, you can either choose to prove the right disjunct, or you can also prove the left disjunct, which will be R1 rule, right? That's just what some thought over here. Another angle to really think about it is you can see here, we got one of the concrete invariants. Well, thinking this way, this is more like the post-state satisfaction, right? Let me just tell you why I actually look at this specifically, right? There's a reason for that. You can think about this part over here is the post-states satisfaction of the concrete invariance number 5. Invariance 5. On the other hand, if you look at this one over here, A equals 0 or C equals 0 over here, this is really the pre-states satisfaction of the same invariance number 5 over here. So it would definitely make sense to really treat this one as the relevant hypothesis. So the hypothesis, that's my first intuition, right? I would that's how I would do it if I were to do it the first time. And let's go a little bit further with that thought. If I actually want to use this particular hypothesis as relevant, in that case, I cannot just apply the the equality rule from left to right or from right to left right away, because the hypothesis itself is actually a disjunction. Meaning that if I want to replace A by 0, or if I want to replace C by 0, I need to make sure I don't have this disjunction over here. Right? That's very important. If you try to apply the equality rule directly, that would be wrong, because it actually requires that the equality simply stands alone rather than being part of some disjunction. So what we can do is we can try to split these two equality into different independent sequence hypotheses. That's what we can do. And what rule can we use? So that's why this rule is always very useful. Whenever you see any disjunctive hypothesis in your sequence, in that case, you may just want to consider to see if you can split the hypotheses, that particular disjunctive hypothesis into 2, right? Let's say if we did that, A equals 0 will be one independent sequence, C equals 0 will be just another independent sequence. In the case where A can be substituted by 0, in that case, we actually got A over here substituted by 0. 0 larger than 0, by simple arithmetic, it will be false. In that case, we are done according to this rule, right? If false simply implies anything. In that case, false being in the hypothesis, we are done for that branch. What about when C is actually equal to 0? When C is equal to 0, you can see this one over here simply matches the right-hand side of the disjunction in the goal over here. But of course, we cannot just conclude it being proved. We have to somehow make sure we have only C equals 0 the goal alone without the disjunction. And we do have an inference rule to actually make sure we can only prove the right disjunct. That's exactly OR, R2 over here. So once we apply that, we will be able to see only C equals 0 and also C equals 0 over here. In that case, we can use the hypothesis inference, axiom inference rule. Right, so that's about the thinking process. I think that's definitely is more valuable, equally valuable as the proof itself. You definitely want to have some mental sketch or some idea about where you might go. Of course, sometimes there might be different ways for you to apply the inference rule. You're just going to choose the one that will actually work. Maybe there'll be multiple paths that will actually work. You never know until you try. All right, so enough about the insights. Let's now try to lay out the proof properly. Right. So what I'm going to do is I'm actually going to need these two hypotheses, as I said, and A larger than 0 will be useful when I actually got A equals 0 for the substitution, right? So I need to keep both. Well, in that case, I'm going to just apply monotonicity over here. In that case, I'm going to have only two hypotheses left. So I'll get A equals 0 or C equals 0. A larger than 0 entails A minus 1 equals 0 or C equals 0. Right? Everything is reasonable up to now, right? If I can make the box just a little bit smaller, and then I'm going to make it, otherwise I wouldn't have enough space. Okay. All right, so let me make this a little bit smaller over here. All right. After this, we're actually going to split A equals 0 and C equals 0, right? That's something we're going to split. We're going to split it into two independent sequence. In that case, I'm going to say by this particular rule, right? ORL. So if we got disjunctive hypothesis, we can split it into two sequences. One with P, the other one with Q. ORL over here. And we're going to say, in one case, A will be equal to 0, and also we still got A larger than 0. Entails A minus 1 equals 0 or C equals 0, right? So that'll be 1. And of course, I'm going to make it smaller in just one moment. Okay. And just draw that properly. Okay. So this will be 1. Okay, let's okay. Okay, over here, this will be one independent sequence, and let's get the other one. The other one will be C equals 0. C equals 0, and we still need to keep this one here. We shouldn't drop it. And then entails A minus 1 equals 0 or C equals 0. Right? Let's now also box it properly. And let's make it smaller. And then I'm going to make it more explicit that these are two independent sequences we have to discharge separately. Okay, so let's put it here. All right, very good. Right, you can see after the ORL rule, we actually got these two sequences to be proved. All right, so far so good. And let's do the top one first. So here we got A is equal to 0 over here. Left hand side, right hand side. We want to replace every occurrence of A by 0. In that case, we want to go from left to right. So far, all this every time we actually apply for this particular rule, we actually got from left to right. But just be careful, it's not necessarily the case every time. If, for whatever reason, if somehow this appears as 0 equals A, in that case, you don't really go from left to right. You go from right to left, right? It's possible. I'm not saying that's impossible, all right? Just keep in mind. And then A is here, right? So we're going to go from left to right. So we're going to apply this rule over here. So we're going to say EQ LR. And as we said, normally after the substitution, this hypothesis that we used for this inverse rule over here can be dropped. In this case, we can definitely drop it. We don't need it anymore, right? So I'm going to apply two rules at the same time. Okay, monotonicity over here. Right, so here I'm going to replace every occurrence of A over here just by 0. So what I will get is I'm going to get 0 larger than 0 entails. So here I got 0 minus 1. 0 minus 1 equals 0, or C equals 0. Right? We're getting very close, but not there quite yet. We got to make sure we do every step properly. Okay. Okay, let me just get it a little bit smaller over here. Right, so what else do we do? We definitely just want to simplify this to be false, really, but we can simplify this at the same time, right? So what we'll do is we're going to say by the simple arithmetic rule, what we'll get is this part over here, right? So this part here, that's what we want to simplify. This one here as well. And this part here will just be false. Entails minus 1 equals 0, or C equals 0, right? And let's just make it just smaller. I think we just need one more application to finish that. Okay, this one over here and that one there can be proved just by using one of the axiom rule. Which one would that be? Oh, actually, let me just make sure it's actually boxed properly over here. All right, over here. All right, you can see this one here is really matching this pattern over here, right? So by false L, we can prove it, right? We might just be able to make a little bit more room over here. Just bear with me. I'll do that quickly. And we can put everything over here to the left a little bit. Alrighty. Okay, we can finish the left branch, the top branch, by applying this one, right? False L. False L. Right? That top branch is done. It's done. So I would say check over here. What about this one over here? And for this one over here, let's see how we can do it. This one here, do we actually want to use the substitution? Let's see. C equals 0 over here, and actually we don't need to. Well, you can definitely try. You might be wondering, maybe I can replace every occurrence of C. You know what? That will actually work. I can tell you. I'll tell you why. I'll give you another alternative proof over here. So here, you can definitely try to substitute C over here by 0. That means you're going to get 0 equals 0 over here. By simple arithmetic, that part over there is going to be true. If it is true, we can choose to only prove this particular right-hand side over here. In that case, we can match one of the rules to say if the true actually appears to the right of the turnstile, in that case, it's also proved. That's another proof you can definitely try. That's why I said before, for a single sequence, there might be multiple ways to prove it, right? So don't be too surprised if for a particular sequence in the exam or in the test, I might just want you to demonstrate 2 different ways to prove it, right? That's another possible question I might ask. All right, for this one here, let's do just do the original way, which I brought to you in the insight. So by monotonicity over here, actually, sorry, not by monotonicity. We want to simply just prove this one over here. That's all we want to prove, right? How do we choose that one there? What's the rule? Well, to do that, we're going to say OR, R2, right? In that case, we can only choose to prove the right disjunct. In that case, we're going to get, so by OR, R2. Right? So that one will allow us to actually put C equals 0, A larger than 0, and then only keep this one, C equals 0. Right? And we are basically done. Actually, for this one, it's rather simple, right? You can see now we actually got hypothesis and the goal happen to match. In that case, we can definitely try to do the hypothesis rule, right? So we can prove it by applying the axiom inference rule. Hypothesis, right? Good. So now we are done with this branch as well, right? So now the sequence is discharged. And do you actually try to also think about the other possible way to actually prove this, what I said before, right? By using the equality left to right over here from this point, rather than using the ORR2. You can definitely do it as well.